We know dinosaurs existed, and we learn more about them every day. What were they like? How can we learn even more? It's like piecing together a puzzle when you don't know what the final picture will be. You know, for centuries, people on every continent have found fossilized remains, but have had no idea what the bones were. The first person to understand that these creatures were different than any other was Sir Richard Owen, a 19th century comparative anatomist and reptile expert. In 1841, he named them Dinosauria, or terribly great reptiles. But did they really live 65 million years ago, as we've been told? If you're a Christian, then the timeline is important. If the dinosaurs went extinct before humans existed, then what does that mean about death after Adam's sin? And if the dinosaurs lived in the time of humans, were they on Noah's Ark? Did they too die in a global flood? Does the existence of dinosaurs contradict the Bible? I'm Marcus Lloyd, and in this series, we're going to look for the answers to those questions and more. So, let's get started. Let's start digging into dinosaurs. Once, we shared our world with strange creatures, whole kinds of animals that vanished not so long ago, leaving only traces behind. What happened to them? Did they slowly go extinct? Or was it something sudden, something global and cataclysmic? Can science answer these questions? Can the Bible unravel this mystery? In this series, we'll look to both science and the Bible to help bring dinosaurs back to life, to find some answers to the many questions they have left us. Uncovering the truth about dinosaurs. Digging into dinosaurs. Scientists at the excavation site we're heading toward use the most modern equipment and technology to unlock the mysteries buried in these hills. So far, there have been about 60 kinds of dinosaurs found throughout the world. Between the 1870s and 1890s, rivalries between scientists fueled a great dinosaur rush. While those years brought many advancements in the study of dinosaurs, the most amazing discoveries actually happened in the last few decades, in places like this. Wow, this is amazing. Here, scientists are listening to the stories these bones have to tell.
Paleontologists see the layers of rock on the Earth kind of like pages in a book. Sort of picture a book on its front cover, laying there with the pages horizontally, with the first page being at the bottom, and the subsequent pages all the way to the end of the book piled up on top of it. And that picture each page as a layer of rock, expand that up to half a mile total thickness to a mile, in some cases even thicker than that. So what you're looking at are layers of rock that correspond to pages in a book. Read each page, starting at the bottom, moving to the top. You're reading through time, reading about the history of the Earth through time. Unlike books, not all the pages in this book of the Earth are there. Some of them have washed away. Some of them have been destroyed in some way or another, or they're fragmentary. As a paleontologist, when I see a fossil, I don't see evidence of death, I see evidence of life. But my second response to it is, so how did it get this way? How did it get to where it's not alive? So as a paleontologist, my second job, in a sense, is to sort of be a forensic pathologist, like a person who's at a crime scene trying to figure out what happened. If we go back a century and a half or so, we had what we call the Bone Wars. They just discovered dinosaurs for the first time. It's like, whoa, these are cool. And so they dig them up out of the ground and they'd haul these bones to various places. And you know what? They lost the crime scene. They destroyed the crime scenes. They put the bones together that were broken, and then they assembled these beautiful skeletons, but they lost most of the forensic evidence as to what happened, how they got to where they were. So what I'm interested in is actually looking at these bones to figure out how they came to be this way. The fact that we have so many of these things, too, suggests that there's probably a lot of burial going on very quickly, but not like the present. Something unusual is going on. Now, if we kind of pan back a little bit, not just one bone, we find them in great masses. Now the story becomes even more interesting because we haven't just found an individual body. We found hundreds of bodies. We're going to want to know what in the world happened. And that's what we got with the dinosaurs.
It's like we only have fragments of the pages in our book. For all we know, entire chapters could be missing. We have to track down every possible source to reconstruct this history. Let's begin by taking a closer look at the dinosaurs themselves, starting with one of the world's most famous.
Tyrannosaurus rex sioux, as it's known, was one of the largest T-Rexes ever discovered in South Dakota. And it's actually now residing in the Field Museum in Chicago. What's spectacular about it is it one of the largest and possibly one of the oldest T-Rexes ever discovered, but it's very complete. About 90% of the skeleton is actually real.
Also, Sioux, with its large head, huge skull, showed some design features that indicate to us it would have been a good predator, probably.
Tyrannosaurus rexes in general had very good vision, it appears. They actually had stereoscopic vision. You look at the skeleton and you look straight on, its eyes could look right at you. They had very good vision. A lot of dinosaurs could only see to the side, but T-Rex could look directly at you, right over the top of its nose. And speaking of the nose had a very large olfactory lobe in the brain, so the nose was probably very, very good. Almost like a shark in the water, the T-Rex could smell things probably miles away.
Scientists estimate that Sioux was about the size of a large African elephant, 5 to 7 tons. How does a creature that big end up as a fossil? There's only one way. She had to be buried in layers of sediment before scavengers got her or she decayed. Here's another dinosaur who met a mysterious end.
There's a spectacular Allosaurus specimen called Ebenezer, and it actually is about a 30-foot long Allosaurus. So Allosaurs were pretty big too. And this specimen is about 50% complete. And what's wonderful about this specimen is it has almost a complete skull, has all of its teeth, all 53 teeth are in the skull.
When he was unearthed, his head and neck were separated from the body. There were no bite marks to suggest that a scavenger had torn him apart. Some catastrophic force did this to him.
Ebenezer's head was actually tore loose from its body and transported some distance from its body. Just the type of thing you'd expect in a global flood, where these animals are buried rapidly, torn apart limb from limb, and just laid out there for us to find after the flood today.
It wasn't just one Allosaurus that was found this way. Powerful forces buried dinosaurs like Sioux and Ebenezer in massive fossil beds where thousands of other dinosaurs died. How did it happen? Well, that's a critical question for all Christians. Were the dinosaurs wiped out by the flood as the Bible described? We're going to put all the clues together that we can, gaining evidence and analyzing it until we find our answer.
Eddie is an Edmontosaurus that's on display at the Institute for Creation and Research's offices in Dallas, Texas. And it's spectacular because it's a juvenile. The small dinosaurs are rare to find. You don't really find too many juvenile dinosaurs. And this one seems to be something the order of 3 or 4 years old. Only weighed about 400 or so pounds. It was a nice juvenile-sized dinosaur. Would have been just before its growth spurt. The ornithopods in general were herbivores. They ate exclusively plants, we believe, and they grazed in huge herds.
Eddie's remains were found among swamp animals, ducks, frogs, lizards, turtles, creatures that weren't supposed to be alive at that time, according to secular science. But how did they all end up together? There's another young ornithopod, Leonardo, a Brachioelophosaurus found in Montana, whose remains raise more questions.
We think of mummies as purposefully preserved, like an Egyptian mummy, where people actually mummified the remains of their dead. But there are natural mummies, like, for example, people who got stuck in bogs in England. But Leonardo, as a Brachylophosaurus dinosaur, was mummified in sand, which is weird. So it's a mystery. How do you get a dinosaur locked into sand, and then how do you get it so well preserved that you can see the stomach contents? You can see where the muscle's attached.
Everything's so well preserved in this dinosaur. It had to have been buried very, very rapidly. You only get that type of preservation when you bury something catastrophically in something like a global flood. But what was extra special about Leonardo was it also had its stomach contents. Its last meal was still inside of its stomach. And they could see that it ate ferns, it ate magnolias, and it ate conifers.
A dinosaur with skin? Magnolias in the stomach? These are the type of discoveries that bring us closer to the answers we're looking for.
One of the other major dinosaur groups is the Thyreophora, which means the shield bearers. Not only do we have the stegosaurs and the ankylosaurs, those general categories, but we have lots of varieties in between. There's different types of stegosaurs, all sorts of varieties of different ways the back was covered. When God designed these animals, he designed these animals with a tremendous amount of variety in them. They weren't changing kinds, but there were lots of variety within that kind.
The Stegosaurus, of course, is noted for its plated characteristics, having the plates going along the back. And yet, interestingly enough, we've never found any fossils of Stegosaurus that look like that. We have found the plates lying around the fossilized remains of the creature. And evolutionists, paleontologists can only guess that that is how the plates were associated with the dinosaur. Some say the plates are for heat regulation. Others say it might be some kind of display or perhaps even in terms of defense. The fact is that we're not sure, except it's one more unique created kind of creature.
And then there were the gentle giants, the great sauropods. These were some of the longest and heaviest of all dinosaurs. At one time, ancient swamps would have been full of them. We know this from the vast number of swamp-like plant and animal fossils found around the world.
Of all the sauropods, Brachiosaurus is probably one of the most unusual. When God designed the Brachiosaurus, he made it different than all other sauropodomorphs. He actually had the front legs longer than the back legs. Every other dinosaur, Apatosaurus, Diplodocus, all the other sauropods, the long necks, all of them have shorter front legs and longer back legs. But the Brachiosaurus was built to stand with its head sticking way up into the air. And we see that in some of the Jurassic Park movies.
All that is able to be done because of these beautiful design structures that allow flexibility along with some rigidity to it, that allow lightening of the skeletal structure so that it's not as heavy as you might think, and is all supported by giant columns and pillars. This is a beautiful design that when you look at all the pieces, they work together. And they work together not just for one animal, but for all the wide variety of the different sauropods. They all have slightly different variations on the same design cues.
One of the unique kinds of ceratopsian creatures are the Triceratops. And even Triceratops come in a variety of forms and a variety of shapes and sizes.
Now, all the different species within the Ceratopsia that we know of all have frills. They have these extensions of the bones of their skull that go backwards over the neck. Now, the Triceratops is unusual because it's a solid sheet of bone that goes from the back of the skull all the way to the end of the frill. And then there's these neat little knobs and bony small spikes that rim the perimeter. So what we find is that when we see a feature on an animal like the frill of a ceratopsian, it doesn't just have one function to that feature. Instead, it serves a variety of different purposes, not just for protection, but also for jaw muscles, and probably for display and for species identification and recognition of males and females. We only have part of the picture, but what we do is part of something absolutely stunningly gorgeous.
While the physical details varied, all the important features are in place on these dinosaurs. You don't see evidence that they evolved from another specimen. It's just one gloriously diverse group, as if God created different varieties just for the beauty of them. There's still one more creature to look at, a dinosaur with a reputation as a bloodthirsty killer, thanks to the movie Jurassic Park, the Velociraptor.
Well, velociraptors are another type of theropod dinosaur. Most of these became meat eaters probably after the curse, after man sinned, and then they started eating each other and anything they could probably get. But however, In the movies, velociraptors are made out to be much bigger than they are. Really, the velociraptor was a lot smaller. Its skull was probably only about 6 or 8 inches long in reality, and probably wasn't nearly as vicious or nearly as smart as they're portrayed in the movies.
We can tell from the fossil record that there are about 60 families of dinosaurs. There are 2 major types based on their hip structures.
All dinosaurs can be classified into either lizard hip dinosaurs or bird hip dinosaurs. There's 3 bones in the pelvis. The pubis bone is the one that comes forward in the T-Rex, and so it kind of supports the belly. And that's the lizard hip style. So theropods like T-Rex and Velociraptor had the lizard hip style. Sauropodomorphs, surprisingly the long necks, also had the lizard hip style. All the other types of dinosaurs, there are the 3 varieties, the ornithopods, the thyreophorans, and the ceratopsians, they all had the bird hip style. What's kind of ironic about that is the secular world says that the T-Rexes and the theropods, the velociraptors turned into birds, but yet they have the lizard hip style.
Do these distinctions matter? Yes. It's important to know whether dinosaurs evolved into modern birds and reptiles, as is widely believed, or whether they always existed just as God designed them. First, we need to look at what a dinosaur is and isn't. We need to understand the difference between them and modern-day reptiles. See, scientists used to think that all dinosaurs moved like alligators, with their legs out to the side, bellies and tails dragging. But Richard Owen and others noticed something in the hip structure of dinosaur fossils. The legs came straight down from the body, which meant they moved more like a rhinoceros or an elephant. We've also found thousands of dinosaur footprints that show an upright position with the feet close together. We find very few signs that any of them drag their bellies on the ground.
Well, one of the features on this femur shows us something that all dinosaurs have, whether it's this little Thescelosaurus, a big T-Rex, or even the Triceratops that's behind me. All of them have a femur that turns inward at the top and points in towards the hip socket, so that this animal's femur sits in a socket sort of like ours, but is physically constructed a little bit different. So all dinosaurs have this feature. There's about 7 other features that all dinosaurs possess in order to identify themselves as dinosaurs. Some of them are bones in the skull, certain ways that they split. Others are ones such as the neck vertebrae. And it doesn't matter what dinosaur you are, all of them have these particular features. There are other features in the lower parts of the leg and the ankle bones as well. Dinosaurs all held their tails out straight of their body. We know this because we have hundreds, thousands of dinosaur tracks around the world and no evidence of tail drag marks along with them. The footprints are the only thing that are there. They're not dragging their bellies, they're not dragging their tails.
We know from fossil evidence that dinosaurs lived all over the world. Many scientists agree that Earth once had a single supercontinent, and then at some point, and for reasons we'll discuss, this supercontinent broke apart, and the pieces drifted to what we know as the continents today. We know from geology that many of the places that are now dry were once tropical wetlands. We know from fossils that much of the Earth was a warmer climate then, and it was filled with plants like ferns and conifers. Scientists have found evidence of grass in fossilized dung of sauropods. And if you remember from Job 40, the behemoth was a grass eater. Look now at the behemoth, which I made along with you. He eats grass like an ox. But most evolutionists don't believe grass existed then. Whose view makes more sense? Researchers have found original tissue in the brow horn of a fossilized Triceratops, but soft tissue decays at a rapid rate. So that raises questions about how dinosaurs could be tens of millions of years old. And it raises the possibility that they lived in the time of humans. If humans coexisted with dinosaurs, then Noah took them on the ark. But how can that be? Those things were huge. How could they possibly fit?
So we have a variety of dinosaurs, from very, very small dinosaurs, again about the size of birds, all the way up to these big, huge sauropods that lumbered through and made a lot of noise, I'm sure, when they walked. They weighed about 50 tons. What we've discovered, though, is the median size, the average size, we like to call it, of a dinosaur is about the size of an American bison.
When we grow up as children, we're sort of captivated by these massive, huge dinosaurs like a Tyrannosaurus rex, the big Brontosaurus. But we don't realize that there's just an equal number of dinosaurs that were really small.
How do we know these things? By comparing fossilized remains. There are multiple types of fossils, and we categorize them by how they were made. The best known is mineralization, where bones are petrified, basically turned to stone. And then there's carbonization, which is a little more rare. This is the imprint of soft tissue. We also have molds and casts, some of which show the external imprints of dinosaur skin. There's what we call trace fossils. These are some of the most exciting. Essentially, they are anything that the dinosaur left behind. This can include footprints and even dinosaur dung. We're learning what these creatures ate by studying their droppings. Scientists have actually found gastroliths, round, smooth stones in the stomach region of dinosaurs that help them digest food.
The fifth type of dinosaur fossil is preservation, and they're finding more and more that dinosaur original soft tissues are and have been preserved in the dinosaurs. They're finding blood cells, they're finding blood vessels.
With every new dinosaur find, with new tools to analyze the discoveries, the shadows begin to lift. The mysteries start to fall away, and we're gaining a deeper understanding of these creatures.
So paleontology is a lot like forensics. You're walking into a crime scene, one that's fossils. And because it's fossils, it's a crime scene that doesn't have any witnesses. The only witnesses are the stones that have a story to tell, but it's the job of the paleontologist to tease that out from the fossils and from the rocks in which we find them.
We're getting one step closer to showing that dinosaur fossils are not as old as you've been led to believe.